In this video, we will be starting with the concept of linear combination of random variables. We will start with the very basic of it. Now, first of all, let's look at this table. This is a probability distribution table for a discrete random variable x. There are 4 values of x given, 1, 2, 3, 4. The corresponding probabilities are given. Now, there are 2 things that we can calculate. We can calculate Ex, which is the expected value or expectation or the theoretical mean, and we can calculate the variance of this distribution. Now, first of all, let me write down the formula. Expectation of x, that equals to sigma x multiplying with the corresponding probability. Let me work it out for you. This is 1 into 0.1. This is 2 into 0.2, 3 into 0.3, and last but not the least, 4 multiplying with 0.4. Now, sigma means add it all up. Multiply x with its corresponding probability and add it up. What do we get? 1 into 0.1 is 0.1, 2 into 0.2 is 0.4, 3 into 0.3 is 0.9, 4 into 0.4 is 1.6. When we add these 4 up, we get the value as 3.0. This is an exact value. Now let's do the calculation for variance of x. Now, if we have to calculate variance of x, we should know the formula. Variance of x is equals to expectation of x square minus square of expectation of x. Now let's first calculate expectation of x square. The formula for expectation of x square is sigma x square multiplying with the corresponding probability. So this time we have to take the value of x, square it, and then multiply with the corresponding probability. So let's get started. 1 square into 0.1, 2 square into 0.2, 3 square into 0.3, and similarly we have 4 square into 0.4. So this is 1 into 0.1, which is 0.1. This is 4 into 0.2, which is 0.8. This is 3 square, which is 9 into 0.3, which is 2.7. And 4 square is 16 into 0.4, which comes out to be 6.4. Adding all these up, we are getting 6.5 from here, and this is 3.5. That adds up to 10. So expectation of x square is coming out to be 10. Now let's go back and double check the value of expectation of x, which is 3.0. So now we can calculate variance of x, and variance of x is expectation of x square minus square of expectation of x. This is 10 minus 3 square, which is 10 minus 9, which comes out to be 1. So we have done all the calculation for the variable x. We calculated expectation of x square, and then the variance of x. Now there is another variable y. When we do similar calculation for y, we get expectation of y is 7. Expectation of y square comes out to be 50, and then variance of y is coming out to be 1. Now let me write the data for expectation of x, which was 3, and variance of x, which comes out to be 1. Now, do you see any correlation between the variable x and the variable y? What we see is that 1 became a 5, 2 became a 6, 3 became a 7, 4 became a 8. In other words, the variable y equals to x plus 4. A 4 was added to every single value of x and that gave us y. If we compare the expectation, the difference between the two expectation is 4. Since y equals to x plus 4, expectation of y is actually the previous expectation plus the difference 4. But what about the variance? The variance remains the same. That means due to addition, variance does not change. Now let's look at another variable which is w. W takes the values 5, 10, 15 and 20. Expectation of w is 15 and variance of w is 25. Now, does w has any correlation with x? The values of x were 1, 2, 3 and 4. What we observe is that each value is multiplied by 5. So we can say that the variable w is 5 times x. What effect does it have on the expectation? Expectation of x was 3. 3 became 15. In other words, 3 times a factor of 5 is making it 15. What about the variance? Variance of x was 1, but the multiplication factor is 5, but it's increased 25 times. So therefore, I can say 5 square times 1 is giving me 25. So let's summarize what we have studied. If I say y equals to x plus a constant b, expectation of y, which is expectation of x plus b, this is expectation of x plus that constant. This we have seen in the first example. Y was given as x plus 4. Since the variable is increased by 4, every single term in the probability distribution table is increased by 4. Therefore, the expected value is increased by 4. That's the first thing. Now, what about the variance? Variance of y, that equals to variance of x plus b, which is variance of x plus 0. When something is added, the variance is unchanged. Now keep in mind, we are adding a constant. That constant b could be a positive constant, that could be a negative constant. It does not make any difference. Now, what is the second rule that we have studied? Let's say we have the variable w, that is a constant multiplying with x. When we are talking about expectation of w, that is expectation of ax, that is a multiplying with expectation of x. Similarly, variance of w, that is variance of ax, that equals to a square times variance of x. In other words, whatever this constant is, it will come out and multiply for expectation. Whatever this constant is, it will come out square and then multiply for variance. And this was very obvious in this particular example. W is 5 times x. The expected value or the mean is multiplied by 5, whereas the variance of x, which is 1, is multiplied with 5 square. So that is what we have learned in this video.